Hello students, myself Janil Popat. We are discussing earth pressure. This is video part 2. In previous video, we have discussed what is earth pressure, what is active earth pressure, passive earth pressure and earth pressure at rest. Let us move forward in the same topic. Now, we are going to discuss theories given by Rankine. Now, let us first go on to cohesion-less soil like sand, etc. In this first case is dry or moist backfill with no surcharge. So, backfill is dry or moist, but it is not having any surcharge. You must remember surcharge. Surcharge is what? Whatever the angle the soil is making greater than the horizontal angle of retaining wall, that is beta surcharge angle. So here there is no surcharge. Now let us take one example. Let us assume this gray one is retaining wall, this h height. Now if the pressure is acting by these backfill, which is dry or moist, it will have a pressure diagram like this blue lines. It is in a triangular form. Now P0 pressure is acting at which distance? At h by 3 distance, height by 3, because it will act at Cg of that. Now pressure force will be given by some of formulas like this. Now pressure can be given as Pa is equal to Ka into gamma into h. Now gamma is unit weight. So unit weight into height will give you pressure as well as it is an active case or active state earth pressure. So we have to multiply it with Ka, that is earth pressure constant of active earth pressure. Now to find out total force, we will take 1 by 2 K into gamma into h square. Now we already have discussed in the previous lecture that we will do what? We will do area of the triangle for the pressure force. So area of the triangle will be 1/2 base into height. So 1/2 into base. Base is our pressure, that is Ka gamma h, and height is h. So I'll take total pressure force is 1 by 2 Ka gamma h square. So it will act at height h by 3 from base. So we do understand that it will act at Cg of the triangle. Let us move forward and understand numerical of the same theory, same item. Calculate total active thrust on a vertical wall which is having 5 meter height. Now there is a retaining wall given which is having some active earth pressure. Active thrust means active earth pressure, retaining a sand of sand density 1.7 gram per cc, for which phi angle of internal friction is given as 35 degree. The surface of the sand is horizontal and water table is below the bottom of the wall. So as the backfill is horizontal, so there is no surcharge. First thing, and second, another thing is that water table is below bottom of the wall. So in the backfill there will be no moisture due to water table. So there is no submerged soil, right? So let us understand active earth pressure for this. Basically let us write given data for that. Phi 35 degrees, C 0 because it is sand. So we are discussing cohesion-less soil here. H height is given as 5 meter and gamma is given as 1.7 gram per cc. Let us convert gamma into kilonewton per meter cube as 1.7 into 17 kilonewton per meter cube. So here the figure is showing a gray retaining wall made up of concrete or etc. It is having material cohesion-less, which means sand. Now height of the retaining wall is 5 meter and the pressure is acting due to backfill only. There is no surcharge, no water table, no submergence, etc. So we have studied first case and this follows the first case only. So let us find out Ka, active earth pressure coefficient Ka. 1 minus sin phi upon 1 plus sin phi. Phi is given as 35. Putting value of phi, I am getting Ka as 0.27. Now, second component I will need, that is Pa, pressure, active earth pressure, that is Ka into gamma into H. Now, I got Ka, I have gamma, which is 17 kilonewton per meter cube, and H is also given as 5 meter. Putting all three values, I am getting Pa as 22.95 kilonewton per meter square. Now, pressure is in meter square because gamma was kilonewton per meter cube and H was in meter. So, Pa will be kilonewton per meter square. Do remember the units. So now I got active earth pressure, but I have to find total active thrust, which is active earth pressure force. For force, I will multiply or I will calculate area of the triangle, which will be 1/2 base into height. So base will be our pressure K into gamma into H, which is 22.95. H is already given, and into 1 by 2. So Pa will be 1 by 2, 22.95 into 5. So total pressure force will be 57.38 kilonewton. Now this is my total force, which will be acting at what height? H by 3. That means 5 by 3 height. So that's it in the first problem. Let us go to second item given by Rankine. Case 2 of submerged backfill. If the backfill is submerged. Here, for the first case, water on one side. If the water is only on one side of retaining wall, then here this figure is showing water table on one side of the retaining wall as here. So the backfill will be directly submerged because it will be submerged in the water. So pressure diagrams of this will be like this. Two triangles will take place, and first triangle will be as usual K into gamma dash into H. Here gamma dash is what? Submerged unit weight. So the unit weight gap between saturated and unit weight of water. So K gamma dash into H. And second triangle, second pressure will be given or exerted through water. So I will take gamma W into H. So this will be my total pressure on submerged backfill. Let us understand this. Submerged unit weight will be gamma dash. So lateral pressure due to submerged soil, that will be K into gamma dash into H. Lateral pressure due to water will be gamma W into H, as we have discussed. So total pressure at base will be K gamma dash H plus gamma W into H. Now in the second item, submerged backfill but water on both sides. So if the water is on both sides, what will be the situation? Here there will be only one triangle, K gamma dash into H, because you must understand the reason. Both side pressure will ignore or will subtract each other or will balance each other. That is why we have not taken gamma W into H into consideration, because both sides are equal. So Pa will be, total pressure will be K gamma dash into H only. And in the third case, where backfill is partly submerged, like half of the soil, like H1 in the figure is moist soil and H2 is saturated soil. So water table will be at here, or H2 height from the base. Now in this case, how to calculate the pressure? Let us understand this. So here half soil is moist soil and other half is saturated. So in the case of moist soil, there will be only one triangle, but in the case of saturated soil, there will be two triangles. First triangle for submerged unit weight and second for water, as we have seen in second case of the same. Here, let us understand with the write-up. If backfill is moist up to a depth h1, then first triangle will be k into gamma into h1 height. If backfill is saturated up to a depth h2, then there will be two triangles having k gamma dash into h2. So this triangle is having k gamma dash into h2, which is given in the red font, and the second triangle is of due to water, which is gamma w into height h2. So combination of both will take place here. So total pressure intensity can be written as k gamma h1 plus k gamma dash into h2 plus gamma w into h2. Let us understand with a numerical. Compute the intensities of active and passive earth pressure at depth 8 meter in dry cohesion-less soil or sand. So here it is clearly mentioned that it is a sand, with angle of internal friction phi is equal to 30 degree and unit weight 18 kilonewton per meter cube. So gamma is given directly in kilonewton per meter cube, so no need to convert this. What will be the intensities of active and passive earth pressure if water table rises to the ground level? Take saturated unit weight of sand as 22 kilonewton per meter cube. So it is very simple. Question is in two different types. First type, if the soil is dry, and second, if the soil is moist or submerged. So for the first case, we can see the figure here. Retaining wall is like that. Here the earth is or backfill is dry. In the case of dry backfill, we can say one triangle will be there for pressure, and that will be K into gamma into H for active, as well as in the passive Ka will be converted into Kp. Because it is a passive earth pressure, I will multiply it with K into Kp. Now let us understand. Gamma is given, phi is given, H is given. Let us write Ka 1 minus sin phi upon 1 plus sin phi. Sin phi is sin 30 and Ka will be 1 by 3. Now what will be the Kp value? Kp will be 1 upon Ka, because it is 1 plus sin phi upon 1 minus sin phi. So Kp will be 3 here. So Ka and Kp are here. Now in the first case, when soil is dry, let us find out active and passive earth pressure. Pa will be K into gamma into H will be 1/3, because K is 1/3, gamma 18 and H is equal to given as 8. So Pa will be 48 kilonewton per meter square. Here K can be taken as 1 by 3 as 0.3333 etc. But we have to take up to 4 decimals compulsorily. Let us move to passive earth pressure. Pp will be Kp into gamma into H. Here Kp we found out as 3. Gamma is given, H is given. So both passive and active earth pressure are there for if the soil is dry. But if the soil is submerged, so when the soil is submerged, the figure will be like this. In this figure we can see two triangles. First triangle is governed by submerged unit weight of soil, and second triangle is governed by unit weight of water. Now let us calculate submerged unit weight by gamma dash is equal to gamma saturated minus gamma W. So we are deducting saturated unit weight and unit weight of water. Now I am getting gamma dash as 12.19 kilonewton per meter cube. Here I will calculate Pa as Ka gamma dash H plus gamma W into H, where in the passive I will take Kp. K is 1 by 3, gamma dash is 12.19, H is given as 8, putting gamma W as 9.81 and H as 8. I am getting Pa 111 kilonewton per meter square. And for Pp, passive earth pressure, I will count Kp as 3, Kp into gamma dash h plus gamma w into h, and the value comes out as 371 kilonewton per meter square. So this is how we can calculate numerical from an understanding of theories given by Rankine. We will see next cases in the next video. Thank you for your attention.